Hello everyone, and welcome to part 5 of an To Be Astronomer reacts to the flat earth alternative to gravity, which is Incoherent Electrostatic Acceleration. So far I can only say that I very much agree with the incoherent part. Let's continue.
So the gases lose their electric potential and turn into a liquid.
Oh yeah, we briefly scratched on that, where I mentioned that to the best of my knowledge, electric potential change has nothing to do whatsoever with the change of state. This is solely a thermodynamic thing with temperature and pressure and things like that. I did atmospherical physics last term, and there was no mention of the electrostatic potential having any influence on the equation of state.
Down here near the surface, the system is very dynamic, with all the plants and animals breathing, low altitude weather patterns constantly cycling, and Earth releasing gases from the deep at all times. We will never see all the gases lose their potential and turn into a liquid anytime soon, I hope.
First of all, I mean the diagram he's showing here is of course fine, right? That's the classical water cycle, and in this case also aerosol gas cycle. That's fine. That's a fine depiction of the things that are going on. Note how none of these have anything to do with electric potential. Also, the very reason that he thinks that it could just turn, that all of those could just lose their electric potential and turn liquid is somewhat comedic to me.
Now we will get to the incoherent part of the phrase.
Um, Pardon me, but this whole thing has been incoherent since the very beginning.
It is called incoherent because it is not completely polarized, like a magnet, but only slightly on its surface through electrostatic induction.
Also, what bothers me is that by polarized, he means something else that I believe that what I would understand it to be. For me, polarization is a property of light. I don't know of polarization in regards to electrostatics. I do not believe that this is a physical thing, like something that is covered in normal physics, to the best of my knowledge. But it's their definition, and at the end it's just names, right? The names are not important. They can call it incoherent if they wish. And apparently their definition is of incoherent is that it's not fully polarized, and I believe by polarized he means that the charges are separated. We in physics would probably call it dipole moment, right? Because when charges are separated, they have what's called a dipole moment. So I wouldn't call it polarization. That's just weird, the name to me. But let's continue.
A magnet, with all of its potential stored on opposite sides,
Potential is not something that is stored. At least not like not in magnetic terms. You could store potential chemical energy. That's something that you could store, I guess. But potential is not something to be stored. A magnet, just on a microscopic level, has magnetic domains lining up with their positive and negative sides, respectively. And they all point towards one direction, at least in ferromagnetic substances. Dia and paramagnetism and electromagnetism, for that matter, works rather differently. But if we talk about, I believe he talks about the permanent magnet, which is a ferromagnetic substance. In ferromagnets, the thing is just that all of the pluses point towards one side and all of the minuses point towards the other, right? But it has no potential stored anywhere. That thing that he says there is devoid of physical meaning.
would be considered coherent.
So that's their definition. It's coherent if it's like stored at each end, and it's incoherent if it's not I guess. Again, that's not something that you find in physics. That's their definition, right? And here we have, oh, what a beautiful chart of intermolecular interactions. I remember learning parts of those, almost all of these. Yeah, there is polarization actually. I now I want to know. Polarization. Let's just say polarization, and we are talking about physics. Maybe he means. Oh, maybe he means dielectric. Okay. I not gonna lie to you. This term I didn't know. It's just essentially having a dipole moment there, electric dipole moment, and I just said okay. All right, that's fine. It's as I said, it's essentially just a dipole, a moment because you place it in an electric field. Okay, I'm fine with that. Right, I'm okay with that. Fine.
Now these forces are very weak.
Yes,
And
very
only
much so. You have the Van der Waals force, which London dispersion forces. I didn't know that those had another name. I'm very well aware of Van der Waals forces, for example. Those are tiny. The induced dipole forces are smallish. They usually are on particle scales. Polarization can be on slightly larger scales, since it's also between like the contacts of a capacitor and things like that. Yeah, all of these are definitely weak. Those two not so much. I'm kind of missing the metal bonds. Oh yeah, no, they just listed them there. Okay, that's fine then. Yeah, there is a bit more to that, and I think the distinction between weak and others is a bit, but okay, fine enough.
apply a slight pressure along the vector they create.
They apply. I need to hear the full sentence. I'm sorry.
Now these forces are very weak, and only apply a slight pressure along the vector they create.
They apply pressure on the vector they create. Why are we applying pressures now? A vector doesn't have a surface, so pressure being force over distance, over a surface, that makes little sense to me. I just assume he meant force. Very strange sentence. Definitely not some sentence you would hear by someone who's talking about actual physics. But
All other pressure mediation.
and I don't want to blame him when I say, by the way, when I say things like, "Oh, that he doesn't sound like a physicist." This is not me being rude or mean or anything. I'm just mentioning it because I notice it. Right? You don't have to sound like a physicist in order to speak the truth, right? Which he isn't either. But I'm just mentioning it.
Such as buoyancy, atmospheric pressure, and temperature are certainly stronger, but nonetheless, pressure mediations such as buoyancy,
Buoyancy, as you can actually see here. As you can actually see here
all
in
other
the
pressure mediations.
pressure mediations, also interesting. Never heard of that word before. Notice how there's a little g in here, which is the g from gravity. Just saying, I think it's so funny when flat earthers invoke density and buoyancy, because it literally requires gravity, so that's just saying gravity again. So that's fun.
Such as buoyancy, atmosphere.
Now, what he has here is not something like atmospheric pressure. What he has here is the radiation, or like the heat transfer of the atmosphere, right? Where you have long wave radiation being able to escape, short wave radiation being partially trapped. You have convection, you have shallow and high convection, and things like that. Seems like a bit of a misplaced picture to me, but I mean, it's fine.
Atmospheric pressure and temperature are certainly stronger.
So he's saying that the pressures that are exceeded by these things are stronger than that of like his incoherent electrostatic acceleration thingy, which neither are. I think it's curious that he starts with pressures and not with anything else like forces or accelerations, because that's unnecessarily complicated to have a pressure as your starting point. But that's why not, I guess.
But nonetheless, these weak electrostatic forces are ever present in the world around us, and I fear the day they may come to an end.
Oh boy, yeah, they will come to an end. Sure. That. Oh god. Why would they do that? Why would they come to an end exactly?
Again, I fully understand people's reluctancy to use the word gravity when speaking of this place we live.
No, you misunderstand. Only people who kind of don't know what they're talking about kind of refuse to use gravity, right? Because gravity is such a simple and yet such an elegant explanation of the things that are going on. Yeah, that's. I mean, I love how they get away with gravity, right? Because that's something that they very much dislike, and yet they cannot come up with any suitable alternative. I mean, this incoherent electrostatic acceleration is already a very poor idea, right? You only need to think a bit about it. What about when the polarization were to change near high voltage thingies, for example? Would suddenly the direction of gravity, would this suddenly flip? Debunking or debating us something, DFE Bryant Myers talked about that the direction would flip during a thunderstorm, for example, which is not something that we observe. Even during a thunderstorm, when you look at that, you still you stay on the ground. You don't start floating. So I love how it's just such a poor explanation when you look at it with even a rudimentary knowledge of the laws of physics, and especially of electrodynamics in this case. And yet they go on and on about it. I love it. And then at the end they say, well, it's no surprise that no one wants to invoke gravity, as if it is even a feasible alternative to gravity. It amazes.
So instead, let's call it what it really is.
What is it?
Incoherent electrostatic acceleration.
It's not.
Let's teach those just finding out the nature of this world in which we live the correct way. The fact that we...
But you barely have anything to teach. You've not gone into any of the numbers, any of them. If you have a physics student, right, and he were to neutrally, they were to neutrally weigh between the established laws and theories of why things fall down, or the downward vector, which is something that is about, and this electrostatic thingy, you can fill whole books full of the explanations of what creates a downward vector, and you can fill another book with only electrodynamics. And he hasn't been able to show a single numerical example, not a single one. That's because he doesn't have any. It's like, yeah, that's the explanation, and that's it. I'm not going to talk about it any further. That's like the thing that I'm so fascinated by a lot of the times with science deniers, like flat earthers and anti-vaxxers and the young earth creationists, which is kind of an overlap with flat earthers for a large part of the group, is that by them just saying things like, oh, it's incoherent electrostatic acceleration, and offering the most basic of very poorly thought out explanations, as if this was in any kind of honest competition to what is already there. That it bamboozles. Sorry, I can't speak. This bamboozles me every time. And the same is for here. You've shown nothing at all. And yet you say, no, you're complete.
We live in an electric realm with a static electric field. You yourself can go...
Yeah, we have a static electric field. I'm not doubting that, but it's not responsible for the things that you claim it is at all.
...out and measure. Tells us without a doubt that these well understood...
Without a doubt. He hasn't even made any experiment on that. He had, I mean, he has done that thing with the balloons that you couldn't see, which is kind of funny, but okay. Um, he, without making any numerical things, he hasn't written down a single equation. And here he shows from the MIT course, I believe, on electrodynamics probably, or electronics or something, whatever it's called, where they talk about the intro to electrodynamics or electrostatics even, which is as if that would confirm his model. Show us how it confirms it.
The laws of electricity create the downward bias phenomena we witness all across the plane.
Why doesn't it change around strong electromagnetic fields? Why doesn't it change around a Van de Graaff generator? When we are at the university, we have an particle accelerator there that has an acceleration voltage of 3 megavolts. 3 megavolts! On his model, where the static field is responsible for that, which you can say you roughly have 100 volts per meter, right? On his model, this would be the voltage that's equal to, think about it for a second. We have 3 megavolts of acceleration current in the particle accelerator, right? That's so much more than his few puny meters of height. And yet I can enter the basement and I'm not being flung to the wall down there.
Instead of using the word gravitation, I ask you to educate.
I'm kind of bothered by that. No one uses the word gravitation. It's called gravity, right? I mean, or is that a thing that's a thing in England or like in America that you use gravitation? I wouldn't know, but maybe.
Educate yourself further on incoherent electrostatic acceleration.
Yeah, there is no thing to be educated about further because it's not a thing. I'd ask you to read a book about electrodynamics, but I doubt that you had the facilities to understand it properly.
This is Good Times for All here, signing out. As always, thanks for watching.
But credit where credit's due, he's not one of the aggressive flat earthers that you have anyway, and he's somewhat pleasant to listen to, right? So, with that, I believe it's a fitting end to part 1. He has made part 2. There is part 2 right here. I've watched the first 15 seconds about it. And this will be where I start my next episode. With that, I thank you very much for watching. Maybe consider leaving a like, or dare I suggest even subscribing. And thank you very much for watching, and until the next time.